Rim.
Yes, sir.
Okay, so today we are going to start a new chapter, that is aldehyde, ketones, and carboxylic acid. And this chapter is also known as carbonyl compound. Carbonyl compound. So, what is carbonyl compound? So, basically, any functional group in which C double bond O is present, that is known as carbonyl compound. The functional group which is with which C double bond O is present. Please write the name. Yes. So any functional group in which C double bond O is present, that functional group is known as, or that compound is known as carbonyl compound. So I'm going to take some example of this carbonyl compound. So here it is. It's very easy to recognize which functional group is which. So please do write with me. So these are some examples of the carbonyl compounds. And if you don't recognize the functional group, it will be very tough for you to write the product in a reaction. So it's very important to recognize the functional group. This is your aldehyde. You can see C double bond O. So it is a carbonyl compound. This is ketone, C double bond O. It is also, all these are carbonyl compound because you can see C double bond O is present, right? I mean,
Yes, sir.
so please do write it and let me know when you are done with this. In this chapter, there are some common names that you need to remember. That is very important. And IUPAC, that's always important. So please do let me know when you are done with this. Then we are going to. Are you done with this?
Done, sir.
Very good. Madhya, we just started aldehyde ketones and carboxylic acid, also known as carbonyl compound. And what is carbonyl compound? Any functional group in which C double bond O is present, that is known as carbonyl compound. So these all are carbonyl compound. Can I change the slide? Please do let me know. Ayman and
Yes, sir.
Madhya. Okay, thank you. Now moving to the next part, nomenclature. And before nomenclature, I would like to and this part we are going to do only for aldehydes and ketones. We will separately study the carboxylic acid, but in a few classes we will only deal with this aldehyde. After completing this, we are going to deal with uh, carboxylic acid. So first we are going to see some common name of aldehyde as well as uh, ketone. So I'm going to write CH3CHO, and it's very important. It's given in NCERT also. So this is acetaldehyde. This is your benzaldehyde. Its common name is basically benzaldehyde, but nowadays this benzaldehyde, its common name is now treated as IUPAC benzaldehyde. There is another, this is CH3, this is CH, there is Br, and now this is your CH2, and this is your C double bond OH. Now you can see that this is your functional group. So this carbon, which is directly attached with the functional group carbon, that is alpha carbon, this is beta, and this is gamma. And its common name will be very easy, beta bromo. We will say beta bromo butyryl butyryl dehyde. This is the common name of this. Now there are some ketone that we are going to learn. This is CH3, C double bond O, CH3. Its IUPAC name is propanone, but its common name is acetone. Its common name is acetone. Now we are going to deal with this, and its common name is acetophenone. Its common name is acetophenone. You can also write its IUPAC name like 1-phenyl ethane 1-on ethanol. No, 1-2, 1-2. Okay, it's good. And its common name is propiophenol. Propiophenol. So please do write it. And there is another compound which is very important that we call benzophenol. So I'm going to write the structure of that as well. So this will be your benzophenol. So these are some common names that you may remember, which is important. Please do let me know when you are done with this. Then we are going to deal with IUPAC first, and then the structure. Then we will start preparation. So I think you can do the IUPAC easily. Do let me know when you are done with this. Are you done with this?
Yes, sir.
Okay, Ayman.
Yes, sir.
Now see, we are going to deal with this IUPAC, and its IUPAC is very easy. As you know, if aldehyde is there, then its name will be al, and with al, and ketone is there, then its name and with on. But always remember that this aldehyde is more senior, or aldehyde is senior than ketone. Aldehyde is senior than ketone. So basically, what I want to say is that when both the functional group present in a compound, then we will give preference to this. That means it is more senior functional group. That means basically we will take it as main functional group. Then this functional group will be treated as substituent, and when it will be treated as substituent, then its name will be oxo. Its name will be oxo. Like alcohol, we use all for alcohol, but when OH is treated as substituent, we use hydroxide hydrox we use hydrox. Is that clear to everyone? Rim, Hammond, Madiha.
Yes, sir.
Okay. So I'm going to give you some question which is very easy. So please do this and let me know the IUPAC name of the following. You just need to write the name of the IUPAC name of the following. Rim, if you have any doubt, you can ask me. Everyone, please do send the nomenclature in chat box, or you can either tell me directly. I'm waiting for your answer. I'll give you one or two or four more IUPAC, then we'll move to the structure. Everyone done with this? Aman, are you done with the first one? Can you name the first one?
So it's ethanol.
Ethanol. Did you say ethanol?
So ethanol.
Ethanol. So it's right now ethanol. What about the second one? It's ethanol. Madiha. Rim. So see what is the functional group present here? Here it is the functional group 1, 2, 3, 4, 5, 6, 7 carbon in the parent chain, in which two branches are there here and here. So going to name it. So we name it alphabetically. So the name will be 4-bromo, 3-methyl, 4-bromo, 3-methyl, hap, and all are singly bonded. So in 1-al or haptal. Is that clear? Aman, it was so easy, man.
Yes, sir.
Rim. Now the next, see, it is the what it is. It is ketone. So naming and numbering it 1, 2, 3. This is your branch. So what its name will be, you can see 3-methyl and see cyclopentane, all are singly bonded. Since it is cyclic, cyclopent, because 5 carbon are there, all are singly bonded, pentane. And on first position, ketone is there, so pentanone. Isn't it easy? Now go for this. This is a spacer. This is your spacer. I would like to hold it here for a while and I'll move it here. See, I'm going to explain this. If you are going to number it from 1, 2, 3, 4, 5, 6, everyone please focus it. When you are unable to count the carbon of aldehyde, then you will use carbaldehyde instead of al. Instead of al, you are going to use carbaldehyde. So when you are unable to or you don't count carbon of aldehyde, since I didn't count in the parent chain this carbon, so the name will be cyclohexane and then carbaldehyde. The name will be cyclohexane carbaldehyde. When you are unable to or you don't count the carbon of aldehyde, then we will use carbaldehyde. Is that clear, all of you? Aman,
Yes, sir.
Rim, Madhya, please do respond. Now see, its name is so easy. 1, 2, 3, 4, and then 5. Why I did numbering from here? Because functional group is here and we give preference to functional group. Now there is no substituent, so jump to the parent chain. How many carbon? Pen. Now see the nature of bond. Double bond is present. So at second position it is ene, and at first position it is al. So we can also write pen to enal. Is that clear? Very good. Can I change the slide? I'm going to give you 4 more IUPAC, then move to the structure and preparation. Please do it ASAP. ASAP. Do let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. Rim, why are you not responding at all? Am I audible to you? Mhm. Everyone can see the screen.
Yes, sir.
Please name it. Have you done any nomenclature of this out of this four? Madhya, I mean, only you are left.
Sir, which one would be the functional group?
See, we have two functional group here in the first one, aldehyde and ketones. And I told you, aldehyde is the senior functional group, so we will deal with this. We will give preference to aldehyde.
Okay, sir.
Now, when you have more than one functional group, out of them only one will be parent functional group, and the rest will be treated as substituent. So this is your branch substituent. So I'm gonna write 3 oxo. When ketone is treated as substituent, we write the name oxo. Okay, and then how many how many carbon in the parent chain? 5. So pent, and all are singly bonded, pentane, 1 hull or pentanol. Is that clear?
Yes, sir.
Tell me, are you done with any one of this?
No, sir, I'm doing it.
Okay. I'm waiting.
Sir, I can't do it.
What is the name of the functional group that is present in this second one?
Sir, ketone.
So this is ketone. So you can number it from anywhere. If either you are going to number it from here, the ketone will get third position. If either you are going numbering from left to right, ketone will get the third position in each case. So you can number in any way. Okay. Now see. First, we always write the name of substituent. Is there any substituent in this compound?
No, sir.
Yeah, there is substituent this
Okay, yes.
and this. So what is the name of substituent? CH3 is what?
Methyl.
What is this? Methyl. So
So
at position
2,4-dimethyl.
and 4 dimethyl. It's easy. Now there is no substituent left. Then jump to the parent chain. How many carbon in the parent chain? 5.
5.
That means pent. Okay. And at third position, it is the functional group. Okay.
Okay, sir.
See, I'm going to number it from here. 1, 2, 3. Now you can see these are called CHO, CHO, and CHO. 3 carbon, so prop, and all are singly bonded propane. 1 comma 3. Since I didn't count the number of carbon in each aldehyde, so tricarbaldehyde. Is that clear?
Okay, sir.
This is the functional group, so we are going to give it number 1, 2, 3, 4. This is the branch, so 4 nitro and benzaldehyde. Either you can write benzaldehyde or either you can write 4 nitro. This is nitro, benzene carbaldehyde. Benzene carbaldehyde. Basically, this benzaldehyde was initially common name, but now rated as IUPAC name. And before that, the IUPAC name of this part you can see is benzene carbaldehyde because we didn't count this carbon, so both are correct. Okay.
Yes, sir. I'll copy it down.
Okay. Can I change the slide? Now let's start the structure of carbonyl group. The structure of carbonyl. As you can see, carbonyl, that means C double bond O, and like this. Can you tell me the hybridization of this?
So
Carbon
sp2.
sp2. sp2 has a geometry that is trigonal planar. That means this compound will be planar. Trigonal planar. This compound will be planar. Now, as you can see, if you want to do like this, oxygen is more electronegative, so it will take electron, so it will have negative charge, and this will have positive. Yes or no?
Yes.
Please do write it. It is trigonal planar, and also it's very important to note that I'm gonna write like this. This is doubly bonded. This is carbon. Wait a minute. And since it is trigonal planar, the angle is 120 degree. Please do let me know when you are done with this.
Yes, sir.
Good. Now let's just start preparation. So preparation of aldehydes. First, we will do preparation of aldehydes and ketones together, because these methods can give ketone as well as aldehyde depending upon the reactant. So the first is basically by oxidation of alcohols. By oxidation of alcohols. Now you can see primary alcohols oxidizes into aldehydes, as we have studied it in alcohols, phenols, and ethers. And secondary alcohols oxidizes into ketones. Always. Tertiary alcohols do not oxidize. So if I'm going to write a reaction like this, wait a minute, just let me change it. If there is CH3, CH2OH, and you are going to do oxidation with the help of a oxidizing agent, mild oxidizing agent, then it will be directly converted into aldehyde. Okay. And if you are going to use secondary alcohol like this, then it will be converted into ketone. You have seen what is oxidation: removal of hydrogen either or addition of oxygen. So we just removed hydrogen. We just removed hydrogen from where you can see, wait a minute. We just removed hydrogen from here and double bond took place, and again from here and one of the hydrogen from here, so that this product formed. So we can easily prepare aldehyde as well as ketone by oxidation of alcohol. If it is primary, this is your primary alcohol, and this is your secondary alcohol. Please do write it and let me know. This reaction you have studied in the previous chapter. I explained that position also. Let me know when you are done with this. Are you done with this?
Yes, sir. Done.
Now the next is the next of this part is also the same. As you can see, the next is by dehydrogenation of alcohols. Do you know what does this dehydrogenation means?
So, removal of hydrogen.
Removal of hydrogen. So basically, volatile alcohols, or we can say alcohols in vapor phase. This reaction you have also studied in the previous chapter. Passed through either copper or Ag, silver, at 573 Kelvin. So again, same reaction will be occurred. If you have primary alcohol, dehydrogenation will take place with the copper at 573 Kelvin. So one of the hydrogen and one of the hydrogen from here will go, and you will get CS3 C double bond OH. And again, if you have secondary alcohol, then what will happen? Same reagent we are going to use here, copper at 573 Kelvin. Secondary alcohol will be converted into ketone. The rest will be same as this. Is that clear? Let me know when you are done with this. Are you done with this?
Yes, sir. I'm done.
So this is the second method to prepare aldehyde as well as ketone. Now the third method comes from hydrocarbons. From hydrocarbons, and you have studied this in class 11. How we are going to prepare from hydrocarbons, aldehyde or ketones. It depends upon the reactant whether it will give uh, aldehyde or ketones. So in this, we are going to deal with by ozonolysis, by ozonolysis of alkenes. So what we need to do is it's very simple, and first we are going to react with if there is any alkene CH2 double bond CH2. So you are going to react with O3, that is called ozonolysis. Okay. So what how you are going to deal with this? Just write the reactant as this and make a home. O3 is like this. Just make a O3 like this alongside double bond, and make a home and then break off. Then this will be a evolution. That means it is evolved in air gas. Now, what you have left in the second step, you are going to do hydrolysis in the presence of zinc dust. Now, what you have left on the left hand side, this is CH2O and this is CH2O. So you have two products, CH2O plus CH2. Now, how we are going to represent this? What is this CH2O? C double bond O, H and H. Again, this will be written as since two hydrogen is there, it will make only single bond, and with oxygen there was single bond, but we have to make double bond in order to satisfy this. In this way, you can make you just did you get it?
Yes, sir.
Can I change the slide?
Yes.
Now see. We have another reactant, that is CH3 CH double bond CH2, and you are going to do ozonolysis. So you are going to react this with O3. So what you need to do, just show all the bond except the double bond. This is the way you can do in your own way. So you are going to make a home and then break a home like this. Now you can see on the left, and you are going to do hydrolysis in the presence of Zn so that you can get the product. Now you can see on the left hand side CH3CHO, then on the right hand side CH2O, that means HCH. Is that clear? Can you do the ozonolysis of this?
So by the same method, right?
You, what you just said, I couldn't hear you. Wait a minute. Yes, can you speak again? I mean,
Yes, sir.
yes, what you did you say something?
Yes, sir. I asked you, this should be done by the same method, right?
Yeah,
So,
yeah.
same
Same,
catalyst.
same. Yes.
So we get CH3 CHO plus CHO plus CH3.
Very good. So this is how to deal with this, right? Can I change this slide?
Yes, sir.
Now, if I'm going to give you, no, I'm not gonna change the slide. Just follow the same process. Always make sure when this CH or C single bond, one is O is there, single bond, just make it double in product, okay?
So how will we do the first one, first part?
So it's in the same way that you did. You can see the rest part will be written as it is. and like this, the way you did the previous one. And there is O, and O. Now what you need to do? Make a home, break a home. This and this. Now passing this through hydrolysis and zinc dust. You can see this is your CH3, this is C, and it is connected with oxygen. So single bond. What I told you, just make it a double bond. Now on the right hand side, CH3CHO. Yes or no? Got it?
Okay, sir. Yes.
So I'm gonna give you again a question, then we will move to the next topic. You're going to do the ozonolysis of this. Let me know when you are done with this.
It will be CH3C double bond rho CH3 plus CH3C double bond rho CH3.
Same product, right?
Yes, sir. Same.
Both are like you got the CH3C double bond O CH3, right? 2 times.
Yes, sir.
Okay. Now, if you have a question on ozonolysis of alkene A, we get 2 moles of methanol, 2 moles of ethanol, let's say ethanol. Write the IUPAC. Wait a minute. Write the IUPAC name of A. So basically the question is opposite. What it gave you is an alkene, and you just ozonolysis of alkene, and you got some alkene, aldehyde or ketone. That depends upon the alkene. Now the question is just reversed. You need to calculate the alkene, find the alkene, or write the name of the alkene, and you have given the product ethanol, 2 moles of ethanol. That means we have CH3CHO as 2 times. Is this clear? The questions you have understood? Amen.
Yes, sir.
Now, whenever this type of question will come, what you need to do, just write this in the way I am writing. So CH3CHO, that means C double bond O, and this is H. And this CH3CH, I'm gonna write this O should C double bond O should be along what we call it, same side. Are you getting my point?
Yes, sir.
Can you write this double bond O should be on the same side? And what you need to do, just remove this O2 and bond should be like this. This was like this, then H was there, and now just add this double bond to CC and O2 will be evolved. So can you name the reactant, alkene A? It's very easy. 1, 2, 3, 4. So it is butene. Yes or no?
Yes, sir.
So whenever you have given question like this, whether it will be 2 ethanol or 1 ethanol, 2 pentanol or anything, what you need to do, it just makes you just write the structure and double bond O should be like this, so that you can easily remove this in the form of O2 and add this 2 double bond. Is that clear? Can I change the slide?
Yes, sir. Yes, sir. Yeah.
Can I change the slide?
No, sir. 1 minute.
Please do that. Are you done with this?
Yes, sir.
Okay. If I'm going to give you an alkene on ozonolysis gives 1 mole of, that means 1 mole of ethanol and 1 mole of propanol. Write the IUPAC name of alkene. Please do let me know if you are unable to solve. Should I explain?
No, sir. I'm doing.
What? What
Yes,
you just
sir.
said? And
Yes, sir.
okay,
You
and
explain.
see what you need to do. What is the product that you bought? You can see the product is ethanol. So I'm going to write ethanol here. So it's CH3CHO. And the next is propanol. That is CH3C double bond O CH3. Now I'm going to write this in this way: CH3C double bond OH. And I'm going to write this like, can I write this? What I told you. Just make sure this double bond comes together and this will be removed. Now what you will have, it's very easy to understand. This will be CH3, and this C is with H, so this will be CH double bond C, and then CH3 and CH3. Now you can write it in your own words, like in your own way. Double bond C and then CH3, and then there is a bond CH3. Now you can name it from here 1, 2, 3. This will be wrong because on from right hand side you are getting the same position of double bond along with the substituent you are getting. So its name will be 2-methyl and then bute 2-ene. Is that clear?
Okay, sir.
So Simon, this is it for today. I want to arrange a class on Friday since all remaining students are absent today. I will discuss it on Wednesday. Okay.
Yes, sir.
And
Okay.
please be focused about your studies because November is just finished.
Yes,
Only
sir.
2 days left. So
I have
please
my
start
pre-board exam of chemistry
when?
next week.
Next week.
Yes.
Okay, whatever I taught you, just be confident about that. Just study that hard.
Yes.